Hi, I'm Rex Black, President of RVCS. Welcome to the RVCS YouTube channel. Hey, I hope you enjoy all these free resources that are available here. And do us one favor. We need to keep the lights on and we need your help to do that. So, when you need testing and quality related services, training, consulting, expert services, you name it, let us be one of the bidders on that next job. We don't expect to get all of your business, but we'd like to get a chance. Thanks and enjoy the shows.
So now it's time for our keynote speaks. So we have a guest from over the Atlantic. Rex Black is the former president of ISTQB, International Software Testing Qualifications Board, which Turkish Testing Board is also a part. So welcome, Rex. So you want to... All right. How are you? Wide awake? I did a little tourism yesterday. A little 25-kilometer long walk. Like your beautiful city. If I look a little sore, it's because of my endeavors yesterday. But you do have a beautiful city. It's a very nice place. Very friendly people. I really enjoyed it. So thank you for inviting me to speak tonight. So what I want to talk about here is building quality, building and delivering quality. You can see I'm carrying on the bridge metaphor here for you, right? I've got 4 bridges. We've got a nice bridge. It's Sydney Harbor Bridge, coat hanger they call it. And then not such a nice bridge here. This is down in Washington State, United States. You hear about this? I built this bridge, and it started to kind of vibrate, pinned like a guitar string, and it picked up so much momentum that it just flew apart. Catastrophic failure. There were actually people on this bridge when that happened too, so you can imagine that was not a very happy experience. So there's reliable, there's good, there's quality, and then there's not so good. And obviously we aspire for something rock solid and stable. Bridge at the top, one at the bottom. Okay, so how do we do that? Well, back up a little bit. Why would we even matter? Why would we even care? Okay, it's software, it's not like a bridge flying apart. Well, I think you can ask Toyota about why software quality might be an issue. Now, Toyota, anybody from Toyota throw knives at me or anything for saying this? Toyota made an amazing statement. Their CTO went to the United States Congress, and they asked, is it a software problem? And he said, oh no, it can't be software, we tested it. I couldn't believe he said that. Sure, you tested every single possible thing that could happen. Obviously they didn't test it enough, right? Software is a contributing factor to what's happening there, and it's creating tremendous brand problems. Some of you might remember Apple Newton. So you may have an iPhone. This is Apple's second entry into the handheld computing market. Some of you might remember that they tried once before with this thing called the Newton. Did handwriting recognition. The handwriting recognition was so bad that it became the object of a series of cartoon strips that had worldwide publication. Now, they say there's no such thing as bad publicity, but I think the people involved in that Newton project might beg to differ, killed the product. They had to basically cancel it. Now, you can think, this was 15 years ago, how much money have companies made on PDAs and small handheld devices in that 15-year period when Apple was out of the market because of their failed introduction. And we're not just talking about millions of dollars of lost revenue here, we're talking potentially billions. The speaker earlier was talking about this issue of the 10x, 10 time or 100 time increase cost to repair a bug in production as opposed to prior to release, and that's fairly typical. Also, the waste of time issue. We should be building new features, right? You want your team to be focused on creating new valuable stuff for your customers, not fighting some sort of rearguard action to try to save your customers after you've sent them bad products. Delay of release, I think we're all familiar with this problem, right? As you get closer to the done date, people start to realize we just can't ship this. And then you have opportunity costs associated with that. And if you're in the safety critical business, basically if you make software that makes anything move in the real world, then you have safety critical issues, and that's, you're not just talking about losing money, you're talking about hurting people. Now, I think the thing that we need to keep in mind is we actually know a lot more about how to do this than you would guess. I think the capability to build good software quality is out there, and we have it. We know, and collectively as an industry, a lot of things, we just don't do them. We just don't have the discipline. That's why, Corey, you asked me this morning, who's at fault? You didn't ask all of us. And that's where I would have stuck my hand up. We're all at fault. We don't apply what we know. So, what are some things that I think would be important? I'm going to pick 6 things just because I only have so much time. I could maybe pick 106, but I think the next 6 things that I'm going to cover are really critical. And if you're not doing these 6 things on your projects, you're really setting yourself up for quality problems of one sort or another. I'm going to try to use case studies to illustrate both successful and unsuccessful application of these 6 lessons, these 6 important things to do for quality. Give you some tips, give you some warnings, and I want to point out that all of these case studies are real. These are not hypothetical situations, they're real world situations, most of which I have firsthand experience with from our clients. So, just to lay these out at a high level before I get into the details, good testable requirements. We don't want this, but we don't always get it. We don't always have it. Again, it's a discipline issue. It's not that we don't know how to do this, just that we get in a hurry, we don't have the discipline collectively. I'm not blaming anyone in this room in particular. Again, I think everybody contributes to this. But if you've got good requirements, you get a lot of benefits out of that. Sometimes the benefits can be a surprise, as I'll show you. Manage quality risk throughout the life cycle. Don't wait until the end. This testing bugs out at the end approach doesn't work. I'm not surprisingly in this room when I say that, but how many projects have you seen where that was the main approach to dealing with quality risk? And I've seen it over and over and over again. Let's stop doing that. Integration and integration testing. This is, for some reason, something that tends to be underestimated. Teamwork. You're not going to build a quality product if you don't have people working together. You can do everything else right, but don't have this part, people working together, you're not going to have a quality product. Similarly, you're not going to have a quality product if your people are incompetent. If they don't have the skills to do it, build quality, then you won't get quality, no matter what process you follow. Any of you who have children who have watched your children play sports know exactly what I'm talking about. They're following the same rules as professionals, but it sure doesn't look like professionals, right? So that's a skills issue. And then managing change. Now, there's a lot of talk about, we've got to be agile, we've got to embrace change and so forth. Okay, that's great, but we still have to manage it. So, let's take a look at these in a little more detail. I don't think I'm going to be saying anything revolutionary here on this first bullet point. good, sufficiently detailed, well understood, testable requirements. We've got these, we've got a good foundation for a quality product. And similarly, or conversely, excuse me, to the extent that we don't have these, then we have the beginnings of a software quality problem. And many of you, I'm sure, are familiar with the problem of either don't get good requirements, or you get requirements but they're missing key characteristics like performance and reliability, and then you find all sorts of issues with that. We forgot to think about this. Now, the interesting thing about requirements is they're the obvious benefits of having good requirements, good testable requirements, but we've also seen cases where the benefits were things that you wouldn't even expect. And I'll show you an example of that in a minute. And we've seen cases, on the other hand, where bad requirements ended up being a source of a lot of unexpected grief. So, I think it's fair to say if you understand the requirements, you can build quality, and conversely, if you don't, then you can't. Because how would we build something that was fit for use, fit for purpose, one of the definitions of quality, if we didn't know what it was going to be used for? Right? I also want to point out something. For those of you who are working on projects that are applying Agile methodologies, nowhere in the Agile Manifesto does it say no specified requirements. It does not say that. What it says is that they value running software over detailed specifications. See the difference there? That's not the same as saying don't bother to write anything down. And we see a lot of this with clients that are trying to apply Agile, is they take this black and white interpretation of the Agile Manifesto, and one of the things that they say is, we don't have to write anything down. No. What they're saying is, only write down what you need to write down. So that does not excuse project teams from writing down requirements. Okay, so let me give you an example. Case study. Long-term costs of bad requirements. We have a client. They're good people, they are smart people. And I want to point this out. All the case studies of problems that I'm going to talk about, don't just assume, that couldn't happen to us because we're smarter than that. Every one of these case studies of a problem, these people were smart, but they made a mistake. This particular company, medical software company, had very vague requirements. There were a lot of gaps. There were a lot of things that weren't specified. A lot of testability problems, and they didn't manage them well. They get a phone call from their customer in the middle of the project. You know that the requirement we had for this, that, and the other thing? We want to change that now. We want to make that a little different. And the person would just go in and modify the Word document, no change tracking, send it to the programmers. Here's your requirements. Okay, maybe people get a little confused. Yeah, people get confused, developers get confused, and so surprise, surprise, the code isn't very good. Now, what they found after the fact was there were a lot of data quality problems. Okay, this program is managing safety-critical data related to medical systems. Would it be bad if we had corruption of the data related to people's response to drugs or something like that? Yeah, that would be bad. And so now they found this out. Oh my God, big panic. They've now spent over $100,000 trying to fix the problem, and more to come. Now, they've learned the lesson. They are writing better requirements. It's better to learn the lesson late than never, but it's a near miss, a near-death experience for the company to go through this. Now, another client. This is a case study of success. They're also in the safety-critical systems business. They have really good requirements, and the requirements are documented in a machine-readable way. And my associates and I were working with them, and we realized, hey, this is great. You get testable requirements, well integrated with your FDA, the Food and Drug Administration, which is how medical systems are regulated in the United States. They have requirements for traceability between their tests and the results and the requirements. So they didn't have any problems with that. But here's the unexpected benefit. We found out, requirements are machine readable. So we designed and created this test tool that could go through and based on reading the requirements, the tool reading the requirements, it could automatically traverse through the screens and verify that the right things were happening, and verify that there weren't reliability problems, the screens were correct, and then, oh, by the way, they can figure out how to make it do localization testing for them too. They can check that the screens have been properly localized for the dozens of different languages. The benefits have just kept coming and coming and coming. If you're curious about this, there's this article called Quality Goes Bananas, and don't blame me for the title, it was picked by the editor of Software Testing Performance magazine. But it describes how this tool works. Now the great thing about this tool is it was built in about 4 weeks, total tool budget of $0. Downloaded free stuff off the internet. Okay. So, who would have thought, right? You had good machine-readable requirements, and all of a sudden you were able to do all sorts of reliability and localization and screen flow testing for free. 4 weeks of work. Okay, so another lesson. Don't wait to the end. Don't wait to the end to get serious about quality risks. This happens over and over again. But there are a lot of times when it's very clear during requirements and design that you have risks to the quality of the system. Bad things that could happen that could make your system not satisfy your customers, users, and other stakeholders. That's a quality risk. It could be performance related, it could be reliability related, it could be functional, but many times these things are clear early on in the project. It's clear oftentimes during design. Hey, guess what? You've got complex interfaces. There's a lot of things that could go wrong here. Now, do we want to wait? Probably don't, but many times we do. And this is too bad because you can use models of various kinds, simulations, for example, to identify and remove quality risk during the design period rather than waiting. You can do component integration and system testing rather than just waiting, oh, well, scrub all the bugs out at the end. A lot of times we've seen with clients that you get into situations where you've got this big tsunami of bugs coming at you at the end. You can't fix that. You can't undo the design problems that were introduced earlier at that point. So, example, bad example, failed project. This is really sad because this didn't have to happen. This is a 2-year-long project. In the beginning of that project, one of the senior members of the technical staff built a simple spreadsheet, Excel spreadsheet, that predicted various kinds of performance problems that would happen with the software running on this large, complex server. His predictions were amazing. Resource saturation at exactly the point where he said it would happen, all that. They had this spreadsheet, he showed it around to people, and they said, oh yeah, that's bad, we should probably deal with that, and then they didn't. Okay. Design, implementation, component testing, no follow-up on this. Nobody checking to see, are we having the problems that were predicted in that spreadsheet? We get into integration test, system test, big problems, big server performance problems. So, he said, oh, let's start patching. Let's start patching problems. So, here's the performance on the first run of the performance test. You see this is the response time, that's the desired upper bound, and this is the legal supported load. So the response time should have been no more than that at this level of load. But we can see kind of a problem here. There's the bottleneck happening, right? And then, oh, okay, well let's patch it. Let's throw some hardware at it. Let's do software fixes. Okay, yeah, it's a little better, but guess what? There's the next bottleneck. Oh, let's patch that. Let's throw some more hardware at it. Nope. There's the next bottleneck. We have an expression for this in the United States called peeling the onion. You know, instead of slicing right through the onion, you're going through one layer at a time. And what are you doing if you're peeling an onion? Crying, right? Yes, you're crying. There was a lot of crying, a lot of wailing and gnashing of teeth, and ultimately the project failed because of these performance problems. Okay. Again, these were predicted 18 months in advance of us seeing them in test. Somebody showed us a spreadsheet. These are the things you've got to watch out for. Now, how sad is that? To work on a project where you knew what could have happened, and you just, people didn't follow up on it, right? And it's not one, I can't point at one person, that's the bad person. We all dropped it. Okay? We all should have been on top of this stuff. We're talking about a 2-year project. It had about 100 people on it. We're talking 200 person years of effort lost, wasted. That's sad. Okay, so what could this project have looked like? Well, we saw another example of it in a subsequent project. Again, we had a spreadsheet doing modeling of the resource utilization. And guess what? Instead of ignoring it, design changes were made based on predicted problems until the spreadsheet said, okay, this will work. We're looking good. Then they created a simulation using a tool that's currently called Hyperformix. Some of you might have heard of it. And they were able to run simulations. Found more problems with the design. Fine-tuned the design some more. Notice that at this point there isn't even any hardware or software. It's just a design. As they started to create the hardware and software, there was performance testing at the unit and subsystem level, and that was compared against the simulation. Problems were found in the simulation, problems were found in the implementation, those were fixed. Okay, so once we got into system test, for the most part, the simulation and what we saw and what we wanted to see were matched. Okay? Let me show you an example. Pardon me. Simulation. The simulation for the IMAP server, which is the email server, predicted 45% server utilization at 25,000 users. Okay, that's the prediction of the simulation. We got 2 servers here with load balancing, simulated load of 25,000 users. Look at that. 45% and 41%. Right? 100% minus 59, 100% minus 55. That's pretty good, huh? So we simulated it, we built it, we iteratively refined the simulation based on what was seen as it was being built, and then when we tested it, we found a few problems, but nothing showstopping, nothing fatal to the project. If you want some more details on how we did this, if you go out to the rbcs-us.com basic library page, there's an article called The Right Stuff out there that describes how this process worked. What does this require? Again, discipline. I'm not talking about anything that we can't do. We know how to do this. And we've known that we should do this for a long time. A lot of these concepts stretch all the way back to Fred Brooks, the mythical man month. And the difference between this project and the project I was just talking about, the failed project, discipline. Doing what we already, as an industry, know that we should do. Okay, another lesson here. Stuff needs to work together. Right? Stuff needs to work together. And that's just going to get more and more true, isn't it? Everything is connected to everything else. I mean, I can do phone, web-based banking on my phone now. I can go out, this thing runs Safari, I can access my bank account. So what do we got? We got software running on an iPhone, talking to COBOL on a mainframe. And I can guarantee you that when the guys writing that software for the mainframe wrote it, somebody said, yeah, you know, someday, about 30 years from now, somebody's going to have this phone and it's going to have an internet browser on it and he's going to be using it to transfer money. And those people would have looked at that person and said, where did you come from? Mars? What's the internet? Handheld phone? Right? So everything has to talk to everything else. So this is a challenge for us because just because things work by themselves doesn't mean that they're going to work together. And just because older versions of things work doesn't mean that newer versions of things will work together. And quality risks can compound. You can have a small problem in one component that once it gets down to the other components that it's talking to, that is magnified as a big problem. So, we got to test control flows and data flows across interfaces. We've got to make sure that stuff works together. We got to use continuous integration to make sure that when we break builds or we break interfaces, we found it quick. Now, some people associate continuous integration with agile and iterative. No. This is an idea that's been out there for a long time. And again, it's discipline. It's doing it. Automated unit testing frameworks. Let's use these. And not just for component testing. Let's use them for integration testing. Let's not wait until the end to find integration problems. Okay, so famous example of not thinking about, integration in Ariane 5 rocket. Right? Some of you know this story. Basically, there was a reuse of a piece of software from a previous version, the Ariane 4, and there was an issue with 64-bit floating point versus 16-bit integer, and that was an attempt to share data between two software components, incompatible data types. And so one piece of software got confused. And what happened? Some of you have seen this video. If not, you can go out and take a look at it. I don't want to spend time running it now, but basically the rocket goes up and it starts to tip over because of the miscommunication between these two pieces of software. And at one point you can see it's almost completely sideways, and then they hit the self-destruct button on this thing. And we're talking about $500 million blown up. Oops. You know, how hard would that have been? How hard would it have been to run that integration test? Not very hard. Certainly wouldn't have cost $500 million. And, you know, keep in mind, this was actually a best case outcome. Once they hit the launch button, the best thing that could have happened was $500 million exploded in the air. Super expensive fireworks show. And the worst thing that could have happened is they could have failed to destruct it, and it could have come down and killed some number of people. Now, fortunately, we're talking about French Guiana, where it's launched, so there's limits on how much damage it can be done. But still, there could have been people killed here. Happening in this system, so when somebody writes code and when it's done, they check it in and it's integrated with everything else, and then everything happens periodically, every 4 hours. All of the unit tests, all of the component tests, all of the integration tests are rerun against the code base after checking it's happened. Again, more detailed description of how we did this in the article called Mission Made Possible on our basic library page, but just a quick overview. Here we see the programmers are creating Java code and JUnit component integration tests in their daily development. This is just standard Agile stuff here, right? The test-driven development type of thing happening. Okay. Which, by the way, is not new to Agile. It's another idea that's been around a good 20 years or so. At the end of each day, the programmers check their work in to Perforce, their source code repository, but it's not done yet, so it's just there for safekeeping. But then when it's actually done, the code has been approved, the unit tests all pass, they check it into Perforce labeled as ready for test. And every 4 hours, this cruise control goes and checks Perforce and says, hey, you got anything new checked in the last 4 hours? If the answer is yes, checks out all of the labeled code, everything's been labeled as ready to go, runs the J-test, static test, that look for violations, static analysis, does build, deploys into the test environment, and then it runs all of the tests, every single test that's been built up to that point, creates a status report, emails that to the program leads and managers. Okay. Total tool budget for the development of this was $20,000 for the test license. Everything else was freeware off the internet. Took my associates and I a total of about 18 person weeks, a little less than 18 person weeks to put this together, and that included training everybody how to do it, training on organizing the process, and doing a thorough risk analysis. So again, what's the missing piece? It's not, because again, this was not expensive. And it's not time. 3 people for 6 weeks, 3 consultants for 6 weeks. This is not a time thing. It's the missing piece, discipline. It's just discipline. We know how to do this stuff. We've known how to do this stuff for a long time. We just need to do it. It's all out there. Okay, now, so I've been stressing this discipline. We got to do the stuff that we know we ought to be doing. And we shouldn't be surprised when we don't, and bad things happen. If you don't brush your teeth, then you have dental problems later, right? This is not a shock to anybody. So, let's not rationalize this. We got to have the discipline. But okay, discipline is part of it, but there are other parts. So, teamwork. I think it's not revolutionary to say quality into a product step by step. Right? Every step along the way, we got opportunities to increase the quality of the work products or decrease them. So we got to work together, all of us, requirements engineers, business analysts, developers, testers, users, marketing, sales, tech support. Everybody's got to work together to do this. We're going to have a quality product. And working together doesn't necessarily require that we all be friends. And I don't have to, if I'm on a project, I don't necessarily have to spend a lot of personal time with people. It's great if that happens. It's great if you have friends at work. But that's not what I'm talking about here. What I'm talking about is effectively working together. We have to not be enemies. We have to all agree that quality is an objective that we all have, that we're all responsible for. And we have to be careful not to be enemies, that don't damage work relationships, because once they get damaged, it's very hard to repair. So let me give you an example of that. We went in for one client, we did a big quality process assessment. An associate of mine and I spent about 6 weeks working with these guys on and off various sites, talking to people, talking to everybody we could find, testers and non-testers. And there was a lot of antagonism. There was a lot of enmity between people. So you talk to people outside of the testing organization, you ask them, what's the value of testing? What's the objective? Why do you have testing teams here? What are you trying to accomplish? Most of them would say, testing has no value. We heard that quote over and over again. Testing has no value. And that's bad. If you're a tester and you've got people in your organization who are walking around thinking, this person's a total waste of oxygen. We would be better off without this person. This can't turn out well. The testers, on the other hand, would say, oh, geez, the business analysts, the programmers are all lazy. They wouldn't do anything right if we weren't around to police them. And that's how they saw their role. They saw themselves as quality cops. Everybody loves cops, right? So this is part of the problem, that they're not endearing themselves to people because they're just running around saying, you should do this, you have to do that. Okay, those business analysts, programmers, they just take all sorts of shortcuts and they damage the quality of the product, and we think they're lazy and stupid. Okay, so the testers think that everybody else is lazy and stupid, and everybody else thinks that the testers have no value. And, when we try to talk to people about how would you work together to resolve the situation. Nobody wanted to work together to resolve the situation. They wanted to see the other side fired. All the testers thought that the business analysts and programmers should be replaced, and all the business analysts and programmers thought the testers should be fired and replaced. So, rather fight. They'd rather be right than work together. So, I had a phone call with the executives who sponsored the assessment, and I said, I hate to use cliches here, but this is a classic good news and bad news scenario. And they said, okay, well, what's the good news? I said, the good news is that you're about 18 to 24 months away from having real world-class quality. We looked at the metrics and so forth of their processes and the level of quality that they were delivering. They were good. I said, here's the bad news. You can't get there with the current team. You can't do it because they will not cooperate. They simply will not work together to solve these problems that you have. We had this discussion about what to do, and they said, well, what if we fired some people? I said, who would you pick? They're all equally culpable in this thing because none of them will work with the others. You can't just point to one of them and say, there's the bad guy, get rid of him and everything will get better. I said, well, what if we fired all of the senior managers? I said, you can't do that because the line managers below them spend all of their time running around putting out fires that are caused by the conflict within the team. So you have nobody capable of stepping up to take the place of the managers at the top that are the ones who are really creating the venom. And the bad relationships, the worst parts were the relationships at the top. The senior managers were the ones that would really sit around and spend time trying to figure out how to make their colleagues look bad. Down at the line manager level and the individual contributor level, they were too busy trying to put out the fires to fight. But sadly, none of those people could be promoted. So the end result was that pretty much all of the IT work got outsourced. So everybody got fired. So, no, this is not good. Excuse me. Now, I mean, for those of you who say, well, some amount of conflict is inevitable within an organization, that might be true, but some amount, not that amount, not to the point where you basically commit organizational suicide, right? So we had another project that was the complete opposite of that. We had requirements and design happening in San Jose, California. We had a system vendor in Taiwan, component vendors in Salt Lake City, Utah, a test lab in Taiwan, test lab in Los Angeles. There's a lot of opportunities for miscommunication and relationship issues when you get that many parties involved, but we had good coordination and we worked together as a team. That project we delivered on time, with quality, on budget. Again, this is stuff we know how to do. It's just we don't always do it. When we get along and we work together, we can succeed. If we squabble, we will fail. Okay. So, people have to get along, they have to work together, but they also have to be competent. Again, to go back to the example I was talking about earlier, watching kids